Honors Geometry students, welcome back. Today we're going to continue with our transformations study, and we're going to focus in on translations and vectors. All right, and we're still in the same learning target 2F. I can compare and create transformations in a plane. All right, so our unit is called transformations, but we haven't talked about that yet. So what you need to keep in mind is that a transformation is when we take a figure and we change its location, its orientation, or the size of a figure. Okay, and we have some different terms that we're going to deal with, pre-image and the image. The pre-image is the original figure. And we might call this pre-image triangle ABC. The image is the new or updated version of the image. After a transformation has been applied. Okay? And to kind of keep track of what's happening here, we might label those coordinates of our vertices of our triangle with those little apostrophes. And remember, we talked about this earlier in the year, we might say that is A prime, B prime, C prime when we speak about that. All right, specifically in this unit, we are going to just focus in on transformations that are going to result in a change in location or a change in orientation. Okay, and those are rigid transformations. So earlier in the year we talked about dilations. Think about when you go to the eye doctor and your eyes are dilated, that your pupils get bigger so they can see inside your eyes, make sure they're healthy. So that was a change in size. So we've already done that transformation. Now we're going to talk about rigid transformations, and that preserves distance between points, which really just means same size. Okay, and the three types of rigid transformations we're going to talk about are translations, and that's the one we're going to hit up for today. And later on, we're going to talk about rotations and reflections. All right. So reviewing a term from the other day, we talked about isometry, and an isometry is a transformation in which the original figure and its image are congruent. So, same size, same shape. Okay, so a translation, our focus of today, is an isometry, which means it's going to be same size, same shape, and it does not change orientation. In other words, we are going to pick up and move it. We're not going to twist it. We're not going to flip it. We're not going to turn it. We're just going to pick it straight up and set it down. So just a reminder, our original figure, our pre-image, is ABC. We pick that up and move it to a new location without twisting it. Okay, so our original is ABC because we just have plain old letters. Our image is A prime, B prime, C prime, so that's that's the new version. All right. So example 1 says graph ABC under the translation xy gets mapped to x plus 2 comma y minus 3. So that means every x coordinate, we're going to add 2 to it. And every y coordinate, we'll subtract 3 from it. All right, so A is hanging out at negative 1, 1. Now, if we take our x coordinate of negative 1 and we add 2 to it, A prime is going to be hanging out at 1 comma. And if we look at our y coordinate's hanging out at 1, we're going to subtract 3 from it. So 1 minus 3 gives us negative 2. So A prime is hanging out at 1, negative 2, right here. Okay, we'll go ahead and do the same thing for all. So B is hanging out at 0, 3. Well, to find B prime, we need to add 2 to the x coordinate, so 0 plus 2 is 2. And we will subtract 3 from the y coordinate, so 3 minus 3 is 0. So B prime is hanging out at 2, 0. Last but not least, we have C hanging out at 3, 4. So we take our x coordinate, add 2 to it, so we have 3 plus 2 is 5. Take our y coordinate at 4, subtract 3 from it, 4 minus 3 is 1. So our C prime is hanging out at 5, 1. And we connect. Essentially what just happened here, okay, by adding 2 to our x coordinate, that means we go 2 units to the right. By doing y minus 3, we're going to move 3 units down. So if I take this original pre-image, I move 1, 2 units right, and 1, 2, 3 units down. There is my image. Example 2. Now we are going to identify the translation that maps SQRE to S prime Q prime R prime E prime. All right, we're told it's a translation, so that means it's going to be same size, same shape. So all we need to do is compare 2 of our coordinates. All right, so SQRE, that is our original, or the pre-image. And the one with the primes, that is the new version, or the image. So we need to think about how we get from XY to the new version. All right, so we pick some coordinates. I'm going to look at these S and S primes. You can pick any pair that you would like as long as they match up. To get from S to S prime, I move left 2 units and I move up 3 units. So my horizontal movement, that's with the x, so x minus 2. And my vertical movement, I'm moving up 3 units, so that would be plus 3. So my rule for how to translate is xy gets mapped to x minus 2 comma y plus 3. All right. We also have vectors, and this is what I'd be showing you in if we had our class today. There we go, a little vector action for you.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. I'm doing a demonstration. Oh! Ah! It's so difficult sometimes to get going outside.
All right, so that was our quick little recap on vector. And if you picked up on it, that guy's name was Vector, as you may recognize. And he says he's a mathematical term. Vector is an arrow that indicates direction and magnitude. All right. So the distance and direction of a translation can be expressed as a vector, and we have an initial point, known as the tail, and a terminal point, known as the head. All right, so when we are writing out vectors, our key thing is that we're going to use pointy brackets, okay? And it's going to be represented by an x and y, so how far over we move and how far up we move. Okay, so to get from A to B, I need to move over 1, 2, 3, 4, 5, 6 units, and I'm going to move up 1, 2, 3, 4 units. So I would represent this vector AB as 6, 4. If you want to do this in translation notation, XY would be mapped to, if I'm moving to the right 6 units, x plus 6, and if I'm moving up 4 units, y plus 4. These two are equivalent. All right, so example 3, we're going to use ordered pair notation or vector notation to represent our translation. Okay, so looking, and we're dealing with a translation, so same size, same shape, so it doesn't matter which coordinates we look at, you just pick your favorite. All right, so let's look at C and C prime. I know C is the original, or the pre-image, and I know that C prime is the new, or the image. Okay, order matters because I need to know which direction. All right, so to get from C to C prime, I move over to the right 1, 2, 3, 4 units. Okay, so I'm moving to the right, so that's a positive 4. And I'm moving 1, 2, 3, 4, 5, 6, 7, 8, 9 units. And since I'm moving downward, that's a negative value. So my ordered pair notation would be 4, comma, negative 9, all hanging out in these lovely pointy brackets. All right, one more. It says, what is the image under the translation -1, comma 2? All right, so we are in ordered pair notation or vector notation. This -1 means we are going to move to the left 1 unit. This +2 means we are going to move up 2 units. So if we are working in Notability, we could be a little lazy. Okay, so I'm going to trace that figure. I'm going to move left 1 unit, up 2 units, and here is my new A prime, B prime, C prime. I could also choose to write out those coordinates. A was hanging out at -6, -2. If I move left 1 unit, so -6 minus 1 is -7. Up 2 units, -2 plus 2 has me hanging out at 0, and I can continue through that whole process to figure out where B prime and C prime are located. All right, so your job for today is to tackle your translations and vectors worksheet. We also have our fun-filled formative, and remember you have up to 3 attempts to check that out. I'm going to take a look at our homework for today. Let's see, translations and vectors worksheet. All right, so most of them are pretty straightforward. I'm just going to point out, just get us started. All right, so our rule is xy gets mapped to x plus 5, comma y minus 9. So I'm going to take my x coordinate, add 5 to it. So A prime is hanging out at -6 plus 5, also known as -1. And then my y coordinate is at 3, and I'm going to subtract 9 from it. 3 minus 9, we get -6. All right. I want to point out that when it's talking about the image of A double prime, so you are going to do 2 transformations, or 2 translations more specifically. So move through that version twice. And in fact, you already found A prime in question number 2, so apply that transformation one more time to get A double prime. All right. Cruising along, writing your rules, all that good stuff, writing your vector. Okay, this is what people usually have trouble with plotting this. So AB is a vector with the coordinates of, or the ordered pair notation of 4, comma, -3. It really doesn't matter where A and B are located as long as you are indicating the 4, -3 ordered pair notation. So I'm going to pick a random spot on here. I will make A hang out right here. Actually, I will put it down here so I have some room to move. All right, so I need to move to, I need to move to the right 4 units. So 1, 2, 3, 4. I need to move down 1, 2, 3 units. So right 3, down, right 4, down 3. So if I want to draw in my final vector, here it is, and I wouldn't even include that. Here's my final vector. It doesn't matter where it goes on the grid as long as it fits on there. All right, try out the rest. Please let me know if you have any questions. I will see you online. Bye.